In today's lesson, we are going to be using Pythagorean's theorem to determine whether a triangle is a right triangle or just a regular triangle. So remember, we learned in last lesson what Pythagorean's theorem is and what makes right triangles so unique compared to all the other triangles, because it's saying that if you have two legs, right, and you square the lengths of the legs and add them together, they're going to equal the square of the length of the hypotenuse, which is summarized in the formula a squared plus b squared is c squared. So we have that formula, and we're going to use that formula and plug in our legs and our hypotenuse into that formula to see if it's a right triangle or not. If it doesn't work in that formula, that means it's not a right triangle, and this could be any other types of other types of triangle. It could be an obtuse triangle, a scalene triangle, acute triangle, right? So we have all these different types of triangles that we could have. So Pythagorean's theorem can be used to determine if a triangle is a right triangle or not by substituting the legs and the hypotenuse in the theorem, right? That's what it says up top. That's basically what I just said. All right, so we're going to use this theorem to determine if the triangles are right triangles. And so we have to figure out first, where is the hypotenuse? That's the first thing we have to do. Again, the hypotenuse is the longest side. It's across the right angle. So if my right angle is here, the longest side is going to be across from it. And in this case, it's 15. So we know that is my C, and the other two are my legs, A and B. And it doesn't matter which is A, which is B. The legs are going to be interchangeable. All right, so we have 9 squared plus 12 squared equals 15 squared. Now, if you know your perfect squares off the top of your head, awesome, great. You can just do that, or you could use a calculator. All right, 9 squared is 81. 12 squared is 144. 15 squared is 225. 81 plus 144 is 225. So that means this is a right triangle. All right, this whole thing is a right triangle. Okay, and those are nice because they're nice integer numbers. When you see you'll get into decimals, probably you have to use a calculator and see if it works or not. Okay, now what if they give us just the lengths? They don't give us the diagrams, then like these problems. Okay, so let's look at 5. All right, 3, 8, and square root of 73. Okay, first I got to determine what is the square root of 73. Okay, I want to see if that is the longest side or not. So square root of 73 is about 8.5. So that's going to be my longest side. So if these are my legs, so that I'm going to call my hypotenuse. So if these are my legs, 3 squared plus 8 squared, I want to see if that equals the square root of 73 squared. 3 squared is 9. 8 squared is 64. Square root of 73 squared is 73, right? Because the square of a square root cancels out. And those end up equaling each other. So that means this is a right triangle. Okay, let's look at another one. Let's look at the next one. How about that? Number 6. Okay, we have 5 radical 7. Let's see what that is about in our calculator. 5 radical 7. Okay, 13.2. All right, so let's take a look. That's probably going to be the biggest side. All right, so this is going to be my hypotenuse. So we have 9 squared plus 9 squared. Is that equal to 5 radical 7 squared? Now, you got to be careful when there's a number out in front. All right, we know 9 squared and 9 squared is 81 plus 81. That's pretty simple enough. 5 radical 7 squared is the same thing as, you have to square both numbers. So you have to square the 5 out in front. I want to do that in a different color. Come on. 5 squared, right? And you have to square the other part of it, the square root of 7 squared, which is 25 times 7. 5 squared is 25. Square root of 7 squared cancels out is just 7. So it's 25 times 7. All right, let's use our calculators. 81, 81 plus 81 is 162. And 25 times 7, I have a feeling this is not going to be it. We're finally going to get one. That's not a right triangle. It is 175. So this right here is not a right triangle. Have enough room? I kind of squeezed it in there. All right. So over here, again, be careful. When you square a square root, like over here, we only had to do the square root of 73 squared, which is 73. Here we had to square the number out in front and the radicand. Okay, this is what's called a radical sign. This is a radicand. All right, so you're squaring the square root of 7, which is 7. All right, let's do one more. Yeah, let's do 12 here. Or, yeah, let's do 12. Or, you know what? Let's do 7. Sorry, keep changing my mind. All right, let's take a look at our lengths here. We have this, which I don't know what it is, 6 and 8. So 2 radical 7. Let's see if that's the longest side or not. 2 radical 7, 5.29. All right, so that's the small side. So that's going to be a leg. So that means this is the hypotenuse. So this is going to be the hypotenuse. So in this one, we have 2 radical 7 squared plus 6 squared. Is that going to equal 8 squared? All right, remember, when I square this, we have to square both the number out in front and the radical. Plus 36 is 64. So that becomes then 4. 2 squared is 4. Radical 7 squared is just 7, and the radical sign drops. Plus 36 is 64. I don't have enough room over here. 4 times 7 is 28. 28 plus 36 is 64. And so that means this is a right triangle. This set of numbers is a right triangle. it fits in Pythagorean theorem. Okay, so work through these problems. Again, if it fits into the Pythagorean theorem, it's a triangle. If it doesn't mean it's not a triangle. It just means it just doesn't have a 90-degree angle. So work through these problems. If you have questions, let me know. Thank you for watching.